We are going to start the new chapter, that is chemistry of transition elements. It is written AS level here, but it is you can see it in your syllabus. It is there. Okay, AS. So first of all, we are going to study what is the transition element. Have you ever learned about these transition elements before?
Yes, ma'am.
Okay, so can you tell me what is a transition element?
They have variable. They have
Yes,
colored compounds.
yes, they have variable oxidation state, they are colored compounds. But these are the properties of transition element. What actually is the transition? Why is the name transition? Transition means in between. Okay, as you know that if you are having the periodic table like this, here you are having S block elements, here you are having P block elements, but in the transition in the middle you are having D block elements, and that D block elements are known as transition elements. Okay, so they are found in the D block of the periodic table between groups 2 and 13. That means a transition element belongs to group 3 to 12. Okay? But not all the D block elements are classified as transition elements. Okay? Transition element is a D block element that forms one or more stable ions with an incomplete D subshell. So what is a transition element? It is actually a D block element which forms one or more stable ions with an incomplete D subshell. So some have complete D subshell, okay, so they are not your transition element. So we'll see the exception. First write it down.
Yes, ma'am.
So there are, as I'm telling that there are some exceptions. So scandium and zinc are those exceptions. We do not define scandium and zinc as transition elements. They are D block elements, but they are not your transition elements. Because scandium electronic configuration, its atomic number is 21. Its electronic configuration would be argon is 18, 19, 20, 21. So it forms only one ion, that is scandium 3 plus, after losing all these 3 electrons. So this 3 plus ion, it has no electron in its 3D subshell, so its electronic configuration would be this. Okay, it's just its argon 4. While if we talk about zinc, its configuration is, its atomic number is 30, so its configuration would be argon Cd10 4s2. So it forms only one zinc ion Zn2 plus. Now this Zn2 plus, after removing this 2 plus, it has fully filled the subshell, not incompletely. Okay, but in the definition it says that it should be incompletely filled the subshell. So its electronic configuration would be ArCd10, which is completely filled. So neither scandium nor zinc forms an ion with an incomplete D subshell. Got it?
Yes, ma'am. Yes, ma'am.
These are some elements of like D block elements, transition elements, or also known as D block elements. So its atomic number is 22. Similarly, vanadium is 23. You should know the names and the symbols. Chromium is 24. Manganese is 25. Iron is 26. Cobalt is 27. Nickel is 28. And copper is 29. So the electronic configurations are written here. I hope you know how to write it. 1s2, 2s2, 2p6. 3s2, 3p6, 3p2, and then the 4 principal energy shell, that is 4h. Okay, so in these cases, this chromium and copper, they are very important because they are exceptions. Why they are exceptions? Because see here that here it should be 4s2 first, and then it should be, according to the Occur rule, it should be 4s2 3d4. But due to extra stability of the d5 orbital, it becomes d5 and 4s1. Why? Because d subshell has 5 orbitals, and it is, and you know that half filled and fully filled orbitals are stable. So due to the extra stability, it is 4s1 3d5. Similarly for copper, it is 4s1 3d10, except the general configuration 4s2 3d9, because half filled and fully filled orbitals are extra stable. Clear?
Yes, ma'am.
Write it down.
Yes, ma'am.
Here, the reason is written here that chromium atoms have just one electron in the 4s subshell. The remaining 5 electrons they are arranged in the 3D subshell so that each of its 5 orbitals it is occupied by one electron due to extra stability. Similarly, copper atoms they also have just one electron in the 4s subshell, but the remaining 10 electrons they are arranged in the 3D subshell so that each orbital is filled by the 2 electrons. Okay.
Yes, ma'am. Yes, ma'am.
So, as you say that transition metals have variable oxidation states, so you should know all these variable oxidation states. Titanium is +3, +4. Vanadium, these are most common oxidation states. Okay, so you have to remember all these oxidation states. Manganese, it forms the maximum oxidation state up to +7. Okay, and all these oxidation states you have to remember. Write it down, make it stable.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Yes, ma'am.
So it is a similarity. Why do they show variable oxidation state? Because of the similarity in the energy of 3D and 4s atomic orbitals that make these variable oxidation numbers possible. So there are variable oxidation states. So names of compounds containing these elements they must have their oxidation number included in the brackets like this. Okay, and it should be the Roman number. Write it down.
Yes, ma'am.
So this is an important point here that when transition elements they form ions, when transition elements they form ions, so their atom lose electron from the 4s subshell first, and then they will lose electron from the 3D electrons. So notice that the partially filled d subshells in these examples, vanadium atom it is this. If you want to write down the configuration of vanadium 3 plus, then 2 electrons are lost from 1 4s2 and 1 electron is lost from the 3d free orbital. Similarly, for Fe atom, write down for Fe3 plus ion, and for copper atom, write down for copper 2 plus. What you have to remember first, lose the electron from 4s subshell, and after that, lose the electron from the 3d subshell. Write it down.
Yes, ma'am.
We're going to learn about some physical properties of some transition elements. So they have some physical properties like they are metals, of course. So they have high melting point, high density properties of metals, hard and rigid. So they are useful as construction materials, good conductors of electricity and heat. Okay, so all these properties are of metals also, and all the d block elements are metals. So these are new one, and these are your important one also that they have variable oxidation states. Why we have already studied they behave as catalysts, they form complex ions, and they form colored ions. So each and every property is important. Write it down.
Yes, ma'am.
Next is your redox reaction. So whenever a reaction involves reactants which change their oxidation state, okay, so that reaction is known as redox reaction. Okay, can you tell me the difference between oxidation and reduction?
Oxidation is the gaining of oxygen, and reduction is the losing of oxygen. Reduction it gains electrons, whereas oxidation you lose electrons. In oxidation, the oxidation number increases, and reduction, the oxidation number decreases.
Here in redox reaction, they involve the transfer of electrons, as you say. Remember that a species is reduced when the oxidation state is reduced and the oxidation state changes to a lower value. But an oxidation state is lowered when a species gains electron. That means it is being reduced, so it acts as an oxidizing agent. You know the difference between oxidizing agent and reducing agent?
Yes, ma'am.
Tell me.
Oxidizing agent is the one that reduces another substance. No, it oxidizes another substance and is itself being reduced. And reducing agent is a substance that reduces another object and is itself being oxidized.
Yes, correct. So his name suggests that the oxidizing agent means the substance which is reduced and reducing agent means the substance which is oxidized. Write it down.
Yes, ma'am.
This example, this is the half equation. You can here see that in this half equation, FHC plus. We'll study this afterwards. Yes, first of all, we'll study about the ligand and complex formation. So as you know that the transition elements, they form complex formation. For example, FeH2O6 plus. So it is a complex and its structure is like this, where Fe is the central metal, where 6H2O ligands, these are my ligands, which donates their electron density, okay, to the central metal atom. So it is called as hexa aqua iron because there are 6 water molecules. Water is known as aqua and iron. Okay, and the oxidation state for iron is +2 only because the oxidation state of water is neutral. So this will study the ligands and complex formation. Write it down. Make the structure very neatly. This is an octahedral complex.
Yes, ma'am.
Okay, so let's end the session here only. In the next class, we'll study about Mohs shape.